When drones take to the skies, they face two major challenges: internal wiring breaking from vibration, and being too heavy to fly far. Rigid circuit boards won't fit into compact frames, while flexible ones fail under shock. Thankfully, rigged flex PCBs offer a solution: lightweight and durable. They are specifically engineered to tackle these issues. Why is it essential? Think about it. Drone motors spin at breakneck speeds, generating intense vibration. Ordinary circuits snap at the slightest strain. Plus, every extra gram of PCB weight drains battery life. And in aerial photography or inspections, even a few minutes lost can ruin the mission. With such compact frames, the boards must bend around components. Using rigid and flexible boards separately just won't cut it. How do we achieve the lightness? We use the thinnest possible flexible and rigid substrates, along with narrower copper traces, making it 30% lighter than standard boards. We limit the circuit layers to just 2 or 3, cutting away any excess material to eliminate unnecessary weight. How do we handle vibration? We bond the soft and rigid interfaces firmly to prevent separation. We switch to vibration-resistant adhesive that absorbs shocks. Heavy components are mounted only on the rigid sections and soldered securely. Nothing shakes loose. Here are some tricks. Place a thin, rigid plate near the motor to add a tiny bit of weight for extra rigidity. Keep GPS cables away from motor wires to avoid signal interference from vibrations. Apply thin protective adhesives only to high vibration areas to minimize added weight. Extending drone flight time by 10 minutes. With robust vibration resistance, the footage stays steady and positioning remains accurate. Bottom line, this tiny board keeps the drone flying smoothly and capturing crystal clear footage.